Thalassemia is the name of a group of genetic blood disorders. To understand how thalassemia affects the human body, you must first understand a little about how blood is made. Blood carries oxygen from your lungs to other parts of your body. Oxygen is carried inside the red blood cells by a substance called hemoglobin. Hemoglobin is made of two different kinds of proteins, called alpha and beta globin. A part of these two, gamma and delta globin, are also present there. These globin proteins are made by genes located on pairs of chromosomes. If one or more globin-producing genes is abnormal or missing, there is a drop in globin production which will reduce levels of hemoglobin, decrease red blood cell production, and lead to anemia. When we talk about different types of thalassemia, we might be talking about one of two things: the specific part of hemoglobin that is affected, usually either alpha or beta, or the severity of thalassemia, which is noted by words like trait, carrier, intermedia, or major. People who do not produce enough alpha globin proteins have alpha thalassemia. Alpha globin is made by 4 genes, 2 on each strand of the chromosome 16. Individuals who have 1 or 2 abnormal alpha globin genes have alpha thalassemia trait. Thalassemia trait is simply another way of saying that you carry the genetic trait for thalassemia. A genetic trait is a kind of message or code contained in your body which may pass on to your children, and they may pass it on to their children. An individual with alpha thalassemia trait, defined by the presence of 2 abnormal alpha globin genes, is said to have alpha thalassemia minor. The lack of alpha globin protein has a somewhat greater effect to the patient. Patients with this condition have smaller red blood cells and mild anemia. Alpha thalassemia traits combine in different ways to produce blood disorders that range from mild to severe in their effect on the human body. If both parents carry alpha thalassemia minor, in which the 2 abnormal genes of each parent are on opposite chromosome or transpositions, their children will inherit alpha thalassemia minor. If one parent has alpha thalassemia minor with 2 abnormal alpha globin genes on the same chromosome or cis position, and the other parent has the silent carrier state with single abnormal alpha globin gene on one chromosome, there will be 25% chance in each pregnancy that their child to be born with normal hemoglobin or alpha thalassemia minor, or alpha thalassemia silent carrier, or hemoglobin H disease. In hemoglobin H disease, 3 of the 4 alpha globin genes are abnormal. Hence, the lack of alpha protein is great enough to cause moderate or severe anemia and may cause health problems such as enlarged spleen, bone deformation, and fatigue. If both parents carry alpha thalassemia minor with 2 abnormal globin genes in same chromosome, there will be 25% chance to get normal children, 50% of chance to get children with alpha thalassemia minor, and 25% of chance to get children with inherit Hydrops fetalis, or alpha thalassemia major, in which all 4 alpha globin genes are abnormal. Hydrops fetalis is severe swelling in an unborn baby where they die before or shortly after birth in most cases. People who do not produce enough beta protein have beta thalassemia. Beta globin is made by 2 genes, 1 on each chromosome 11. In beta thalassemia trait, 1 of the 2 genes is abnormal, but lack of the beta protein is not great enough to cause problems in the normal functioning of the hemoglobin. If both parents carry the beta thalassemia trait, 25% of chance to get a child with normal hemoglobin, 50% of chance to get a child with beta thal trait or minor, and 25% of chance to get a child with beta thalassemia major, or Colles anemia, which cause life-threatening anemia that require regular transfusion of blood. In somewhat milder forms, this inheritance of 2 abnormal beta globin genes may cause beta thalassemia intermedia. Beta thalassemia trait can also combine with variant hemoglobin to produce other related blood disorders. If one parent carries the beta thalassemia trait and other parent carries the hemoglobin E trait, 25% of chance for a child with normal hemoglobin, 25% of chance for a child with hemoglobin E trait, 25% of chance for a child with beta thalassemia minor, and 25% of chance for a child with E beta thalassemia. E beta thalassemia cause moderately severe anemia and similar to the symptoms of beta thalassemia intermedia, but occasionally may severe as thalassemia major. If one parent carries the beta thalassemia trait and other parent carries the hemoglobin S trait, which is the abnormal hemoglobin found in people with sickle cell disease, it creates a 25% of equal chance of getting a child with normal hemoglobin or sickle cell trait or beta thal trait or sickle beta thalassemia. The severity of this disease is varying with the amount of normal beta globin produced. This is the summary of today's video. We hope that now you got a clear idea about thalassemia. In our next video, we are going to bring you how to diagnose thalassemia. Until then,
Bye!